All right, so in this video, we're going to be talking about how we name alkanes. All right, so naming organic compounds. And the overall objective is that we're going to name an alkane if I give you the structure, or if I give you the name, you should be able to tell me, or you should be able to draw the structure of the alkane itself. So when it comes to the naming of alkanes, there's pretty much three parts to the name. All right, first you have the prefix. Now the prefix specifies the location of any functional groups or any substituents. So basically, where are the functional groups or other substituents? And we're going to talk about what those are in a little bit. All right. Then we have the parent. Now, the parent basically tells us how many carbons do we have in the main chain, all right, or in the main body chain. So that's what we're basically looking at. And then the suffix basically tells us, what family does the molecule belong to. Okay, and we'll talk about this in just a little bit. So there's pretty much three parts in the name of an organic compound. Or in this case, we're really just talking about alkanes. So we have the prefix, the parent, and then the suffix. So a substituent, it's basically where you have anything that's attached to the main body. All right, so it's just an atom or a group of atoms. All right, so sometimes a functional group could work as well. That's attached to the parent compound. All right, so basically the substituent is attached to the parent, and that's your main chain of carbons, which we'll talk about a little bit later, okay? Now, for our purposes, since we're talking about this video specifically about naming alkanes, all right, so when we're talking about the family, all right, the suffix that we're going to use are just going to have the ending "ane", all right, because these are all alkanes. Now, if we're dealing with alkynes or alkenes, then the suffix will change because it's in a different family, all right? But for this video, what we're going to be looking at specifically are just alkanes. Now, when it comes to the parent, all right, so this is what we're going to talk about now. The parent is basically how many carbons you have in a straight chain, all right? Depending on how many carbons you have depends on the name that you give it, all right? And so let's just kind of go through this. And so, for example, if you have... So let's go ahead and make a chart, right? We're going to have number of carbon atoms, okay? We're going to write its structure, okay? And then let's draw the Lewis structure, so the bigger structure here, so you can see what I'm talking about. Let's have the line structure. That might be helpful. And then let's do the actual name itself. Okay, so these are the categories we're going to look at, all right, in this table here. All right, so let's just say we have one carbon, right? So it's a CH4, and we know it looks something like this, all right? That's its Lewis structure. With one carbon, there's no line structure here, but the name of it is methane. Okay, that's the name. All right, now let's say we have two carbons. So you have CH3CH3. Okay. All right, so its Lewis structure, you have two carbons attached to one another, and it's 6 hydrogens. Okay. The line structure just going to be one straight line here. All right. And then so we call this compound ethane, all right? And when there's 2, it's an F. All right, so what about if we have 3? So we have a CH3, CH2, CH3, All right, how does that look like? Well, we have 3 carbons. All right, so the first one is a CH3, CH2, and then we have this 3. All right, and so we have 3 carbons. So 1, 2, 3. That's its line structure, and we call this compound propane. All right, let's continue on with this chart here. So let's say we have 4, right? So you have CH3, CH2, CH2, CH3. All right, so we have 4 sets of carbons. All right, let's draw all our hydrogens. Okay, so its line structure is 1, 2, 3, 4. So we have 4 carbons here, and this is butane. Okay, so but giving 4. Now we have 5, right? So CH3, CH2, 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 CH3. All right, so we have 5 carbons attached to one another. All right. With the 5, I think we have what? 12 hydrogens. C5H12, right? All right, so let's draw the line structure. 1, 2, 3, 4, 5. All right, and so this is pentane. So if you think of like pentagon, 5-sided building, pentagon, 5-sided shape, really. So pentane, 5 carbons. Okay. Let's continue. All right, so she's gonna move this a little bit here. All right, so 6. Yes, CH3, CH2, 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 CH3. All right, so we got 6 carbons here. All right, so let's attach these 6 carbons. So we have 14 hydrogens now. All right, so 1, 2, 3, 4, 5, 6. That's its line structure. All right, and the name of this compound is hexane. All right, so I'm pretty much sure you guys are slowly getting to a point here. All right, so if you have 7 carbons, I'm not going to draw this out anymore because I don't want to bore you guys too much. But drawing the line structure, you have 1, 2, 3, 4, 5, 6, 7. All right, and so this compound, we call it heptane. All right, if it's 8, you have 1, 2, 3, 4, 5, 6, 7, 8. We call this octane. Okay, we have 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is nonane. All right, and then last one I really care for you guys to know. All right, is if we have 10 carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, this is decane. All right, so this is the naming of the parent straight chain alkanes. All right, and so that's, when you're looking at of each of these prefixes, or when you look at the names, it will give you an idea how many carbons do we have in our overall straight chain carbon. All right, so let's talk about substituents just a little bit more. All right, so we have substituents that we call alkyl groups. All right, now alkyl groups are really just types of alkanes that are just missing a hydrogen, really. Okay, and so let me tell you what I'm talking about here. So, like, for example, if we have CH4, right, we know we call this methane. Okay, if we take away a hydrogen, well, we're going to have a CH3. We call this a methyl group. Okay, all right. If you have another example, if you have all right, so CH3, CH3, we call this ethane. All right. But if we have a CH2CH3, so there you go, we're missing a hydrogen. This is what we call a ethyl group. All right. So it's just an alkane that's missing a hydrogen. All right. And when it's missing a hydrogen, that's kind of the point of where this substituent is bonded to the parent group. All right. If that makes sense. And so let's just kind of talk through all the different alkyl groups that I do want you guys to know. All right. And so like the first two I kind of showed you here, you have methyl, you have ethyl. All right. We have another one. So you have CH3, CH2, CH2. All right. So this is the point where it's bonded to the parent group. We call this propyl, right? That's supposed to be a P. So this is your propyl group, all right? It has 3 carbons, okay? Now there's another version of this propyl group that tends to be a substituent as well, all right? And I'm gonna kind of draw this out carefully so you can see how I'm drawing this, all right? But let's just say you have a CH3CH and then a CH3, all right? When you have, this is your attachment to your parent group, this we call an isopropyl, all right? Which is just a little bit different from a propyl group. And I'm going to draw this for you guys a little bit later so that way you can kind of see what's the difference and how it could possibly look like, all right? But one of the biggest things I want you to watch for is that you notice this is more like a straight line substituent that's attached to the main body, while here it's more like a deviation, like a fork on a road or something, right? Where the carbon, the center carbon is what's attached to the main body. And then you have 2 carbons kind of stemming off of it, like a fork in the road. All right. And so that's your isopropyl group. While this is more like a chain, this is more like a fork. So that's kind of like the biggest difference between the two. All right. Now, let's continue on with this. So another one I want you guys to know. All right. Let's just say we have a CH3, CH2, 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 and it's bonded over here on this side to the main body. We call this butyl, okay? Now, you can imagine, since there's more carbons here, like how or which carbons attached to the main body, it's, you change the name of this, all right? And so, like, for example, let's say that you have this here, and it's attached to the second carbon here, all right? We call this sec-butyl, all right? That's the name of this alkyl group, all right? Here's another one. So we have CH3CH, CH2, CH3. It's bonded to this particular carbon here. We have what we call isobutyl, okay? And we have CH3CCH3. And if this carbon is attached to the main body, we have what we call tert butyl, okay? So these are just the different types of alkyl groups or substituents I want you guys to know and be aware of, all right? So you have 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so you got these 8 that I want you guys to know. And so that when we draw the structure, you guys know exactly what's going on. And as I said, we'll practice this, all right? So just kind of hang on through this video. Now, we also like to annotate special types of carbons depending on how many carbon a particular carbon is attached to, right? And so, like, for example, if we have like ethane, right? So this is ethane here. All right, and what we want to pay attention to is how many carbons is this particular carbon is attached to, right? And if you notice, it's like, well, there's only one other carbon. So what we'll say is that this carbon is a primary carbon, all right? Meaning that it's only attached to one other carbon. This carbon is also a primary carbon, all right? Because that means it's also attached to one other carbon. Well, what if you have something that looks like this? All right. Here we have propane. All right. Now, if you were to pay attention, so we're looking at this carbon. This carbon is only attached to one carbon here. All right. So we will say that this carbon is a primary carbon. All right. And this is also true for this carbon here at the very end, the right end. It's only attached to one carbon. So we'll say that this is a primary carbon. But if you look at the one in the center, the one in the center is actually attached to two different carbons. All right. And so what we'll say is that this carbon is a secondary carbon because this carbon is attached to two other carbon atoms. All right. Well, what if we have something that looks like this? All right, so just trying to increase the complexity. All right, so you have yourself a butane or a C4H10. All right. All right, so it's a butane-like compound. Now, when we're looking at this original carbon here, we see that this carbon is only attached to one. So this is a primary carbon. All right. When we're looking at this carbon here, it's only attached to one as well. So this one is also a primary carbon. Well, when we're looking at this carbon here at the very right, this is also a primary carbon. But when we look at this carbon here, it's attached to 1, 2, 3. So what we'll say is that this right here is a tertiary carbon, all right, because it's attached to 3 other carbons. Now, it's also possible that you may have a carbon that's attached to 4 different carbons, like what I'm drawing here, okay? So we have this carbon that's kind of dead in the center, all right? And it's attached to 4 different carbons. This carbon here, so what we'll say with this carbon here is a quaternary carbon atom because it's attached to 4 other carbon atoms. All right. All right, so let's go ahead and learn to name these alkanes. Okay, so the first thing you want to do, you want to identify the longest continuous chain of carbons. Okay. And so here I have an example of an alkane. And what you want to do is just you want to count to figure out, okay, what is the longest continuous chain of alkanes? Because that's going to be your parent. That's going to be your backbone. Okay. And then we'll base everything off of that. All right. And so the way that you'll count this out is, okay, I will have 1, 2, 3, 4, 5. All right. So that's one particular chain. I also have 1, 2, 3, 4, 5. All right, so in this case, either way works. You could go this way or this way. All right, and so that will be your chain. And so what I'm going to do, I'm going to go ahead and highlight my chain, and everything else, it will be a substituent. Now, the next thing that you're going to do is that you're going to number the carbon atoms in the main chain. You're going to start, the side that you start with is the side that has a substituent that's closest to it. All right, if that makes sense. So you have 2 ends here. You can either start this end or we could start this end. All right. But when we count 1, 2, 3, 4, we have a substituent in carbon 4. But if you start on this side is 1, 2, 3, 4, 5, and you have a substituent on carbon 2. So that means I will want to start numbering from this carbon because you want to start with the end that has the closest substituent to it. All right, and so this is carbon 1, 2, 3, 4, 5. So now the next thing you want to do, you want to able to identify the what substituent you have and what number it is. All right, and so when we're looking at this, it's like, okay, well, this is my substituent, all right, and it's off of carbon 2. Okay, so this is going to be important when it comes to naming it. All right, so I have the substituent, and if you notice, this substituent is actually a methyl group. All right, so this is my substituent, and as I said, it's coming off of carbon 2. Now, remember, first thing I stated in this video that the naming is always in this order, is that you have your prefix, all right, parent, and your suffix, right? Your prefix is the substituent and which carbon's on. Parent is your main body, all right, set of carbons, and a suffix is the family that you're in, all right? And so first we're going to start with the prefix. And so what prefix are we going to use? Well, we're going to number what carbon and what substituent we have. In this case, we have a 2-methyl, so I'm going to write 2-methyl, all right? Now we're going to go to our parent. What is our parent? We have a 5-carbon chain here. So this is a pent, all right? And what family is it in? Well, this is an alkane, so we write ane at the end. So it's a 2-methylpentane. All right, so this is the name of this organic compound, all right? Let's do a couple of more. All right, so here's another example. All right, so the first thing, as I said, you want to determine what's the longest chain, okay? So I'm going to go ahead and count this out. So I have 1, 2, 3, 4, 5, 6. So I have 6 carbons here. I have 1, 2, 3, 4, 5, 6. So I have 6 carbons here. 1, 2, 3, 4, 5. Well, there's 5 carbons here, so now I could count that out. I have 1, 2, 3, 4. Well, this chain only has 4, so that doesn't work. All right, 1, 2, 3, 4, 5. This only has 5. 1, 2, 3, 4. That's only at 4. So really, you have 1, 2, 3, 4, 5, 6. So that's a particular one. Or we have 1, 2, 3, 4, 5, 6. So that one works. All right, so it's like, okay, you could kind of think to yourself, okay, well, what if I have two possible longest one? All right, so it's like, okay, which one do I choose? Well, then you want to choose the one where your substituent has the smallest number, right? Where it comes up with the earlier carbon, right? And so, like, for example, if we start here, if we say that, or for example, we have 1, 2, 3, 4, 5, 6, right? So this is a possible one. Well, this is carbon number 4 where we have substituents coming out. Or we have 1, 2, 3, 4, 5, 6. Well, in this case, this is carbon number 3. So you prefer this direction. And it's the same thing here. 1, 2, 3, 4, 5, 6. So because these two are exactly the same, so you have this long chain or this long chain. If this is the case, because both of them have substituents in carbon number 3, it doesn't matter. You just call any of them because the name won't change. All right. And so for me, we're going to make this our long chain. All right. And so if you notice, we have 2 substituents. We have a substituent up here and we have a substituent down here. Okay. And now let's go ahead and name these substituents. So this is a ethyl group. All right. And then this substituent is a methyl group. All right. Let's go ahead and name our carbons in our main chain, or number them. 1, 2, 3, 4, 5, 6. Okay, so this is what we have here. Now, let's go ahead and name them. Now, when it comes to substituents, if you have multiple substituents, okay, you want to list the substituents in alphabetical order, All right. And so if we look at this, you have ethyl first, so E will come first, and then you have the methyl later. All right. So that's the way that we will name them. All right. So how do we name this? All right. Well, we have 3 ethyl. Okay. So 3 dash ethyl dash 3 dash methyl. Okay. And then when we look at, okay, now we list out our substituents. Let's go ahead and figure out what main body we have here. 1, 2, 3, 4, 5, 6. So this is a hex. And the family of this one is an ane. So the name of this is 3-ethyl 3-methyl hexane. All right, so this is the name of this particular compound. All right, so here's another example. I decided to use the line format instead. All right, but same idea though. It just looks different, but the steps that you need to take is exactly the same. All right, so first thing you want to do is identify what's your longest chain. So I'm looking at this 1, 2, 3, 4, 5, 6. Okay, I have here 1, 2, 3, 4, 5. So this is not our longest chain. So I'm gonna cut that out. I'm gonna look at this 1, 2, 3. Nope. Over here 1, 2, 3, 4. Nope. 1, 2, 3, 4, 5. No. So my longest chain is 1, 2, 3, 4, 5, 6. So I'm going to go ahead and highlight this so that we can see that. All right. So this is our longest chain here. All right. And I'm going to go ahead and number them. All right. So we got to figure out which direction is the best. Is it 1, 2, 3, 4, 5, 6? Or is it 1, 2, 3, 4, 5, 6? Now, obviously, the substituents are coming off of here. So this will be the best direction because you always want to make sure the substituents is the lowest number of carbon possible. All right, so 1, 2, 3, 4, 5, 6. So that tells us already we're dealing with a hexane. All right. Now let's look at our what substituents are we dealing with. All right, so we have this here. This is a methyl group. And we have another methyl group here. So we got 2 methyl groups. All right, so how do we deal with when we have 2 of the same type of substituent? Well, we use prefixes if we have 2 of the same type of substituents. What do I mean by that? All right, if you have 2 of the same substituents, we'll use the prefix di. If there's 3, we'll use tri. If there's 4, you use tetra. All right. 5 of them, they use penta. So the whole point is if you have multiple of the same ones, we use prefixes. We don't list them twice. We just say, like in this case. So let's talk about this case here. So here we notice we have a 3 and we got 2 methyls. So what would be the name of this compound here? All right, we'll list it each time we find a methyl group. All right, so the name of this would be 3, 3 because the methyl groups both comes from the 3rd carbon. So 3, 3 di, show there's 2 of them, dimethyl, and what we have here, we have a hexane. So this is a 3. All right, 3, 3, you have 2 of them, di. All right, both of these are methyl groups, and then because there's 6 carbons here, it's a hexane. All right, so 3,3-dimethyl hexane. All right, so let's look at this one here. I know I went kind of crazy, but still, all right, same process. We just got to make sure, number 1, find your longest chain, figure out your substituents, make sure you number all of your carbons, and then you write the name. All right. And so let's go ahead and figure out the longest chain first. So we have, I'm gonna start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 here. All right. 1, 2, 3, 4, 5. Well, that's not gonna work. 1, 2, 3, 4, 5, 6, 7. Nope. 1, 2, 3, 4, 5, 6, 7, 8. No. 1, 2, 3, 4, 5, 6, 7, 8. Nope. 1, 2, 3, 4, 5, 6, 7. I think that's still 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Well, that doesn't work as well. All right. try from different angles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one works just like that one over there. All right, 1, 2, 3, 4, 5, 6, 7. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, so yeah, that doesn't work. All right, so 1, 2, 3, 4, 5, 6, 7, 8. Nope. 1, 2, 3, 4, 5, 6, 7. Not quite. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, so what I find here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is my longest chain. So this is the one I'm going to highlight. I'm going to highlight this chain right here. So that way, as I highlight it, my substituents will be easier to see. And so I'm going to go ahead and number them. 1, 2, 3, 4, 5. Oh, no, let me not number them yet. Let me figure out first where's my closest substituent. I think I actually nailed it right the first time. Because here, if I go 1, 2, 3, 4, 5, my first substituent come at 5. But if I come from here, 1, 2, 3, my first substituent starts at 3. So yeah, I was right the first time. Okay, so 8, 9, 10. All right, now we got that. So let's go ahead and highlight each of our substituents we have. We have this one here. All right, I have this one here. All right, and then I have this one here. All right, so I have a substituent at carbon 3, carbon 5, and a carbon 6. Cool. So let's go ahead and name each of these substituents. All right, so the one at carbon 3, you have 3, and look like there's 2 carbons. So this one is just a simple of an ethyl group. All right, so we have 3 ethyl here. Now let's look at the one at carbon 5. The one at carbon 5, it's a 5. Now look at this one. All right, so we have 4 carbons here. 1, 2, 3, 4. So it's a type of butyl group, but if you notice, it's this carbon that's attached. So here we have a tertiary carbon, all right, and it's attached to this carbon here. All right, and so if you go back, you want to kind of look at the notes that this configuration is what we call your sec-butyl. All right, so this is your sec-butyl here. All right, and then we have this carbon at the top here, carbon 6. It has its own substituent. All right, and so this one's a 6. But now you notice this is a propyl, all right? So you have three propyls, but the configuration is that this second carbon is what's attached to the main body here, all right? And so this is an isopropyl, okay? All right, now we're going to write this whole thing out. Remember, this is a decane, right? Because you have 10 main body carbon. So let's go ahead and put this in order. I remember we always put this in order, in alphabetical order. So E, then I, then S, and then we write the decane here. So it's a 3 ethyl dash 6 isopropyl dash 5 sec butyl decane. There you go. All right, well, that's conclude this video. All right, and this is a long one as it is. All right, see you in the next one.